Let us discuss the problem of ITG 2004. It is based on expansion of solids and liquids, and also it uses the concept of buoyancy force. The problem is that a cube of certain linear expansion coefficients alpha s is floating in a bath containing a liquid of certain coefficient of volume expansion, say gamma L. That means we have a liquid. In this liquid, a cube is floating, cube is solid. We are given information about linear expansion coefficient of this solid alpha s. We are given information about volume expansion coefficient of this liquid gamma L. It says that when temperature is raised by a certain value delta T, the depth up to which cube is submerged in the liquid remains same. If submergence of solid is of depth h, then with rise in temperature of liquid as well as solid, it is found that h remains same. Based on this information, we have to find a relation between alpha s and gamma L, right? So this was subjective question, but it can be asked nowadays in the form of objective. So first, let us recall that buoyancy force is the force equal to weight of displaced liquid, and that buoyancy force must be balancing the weight of solid, right? Let us find how the weight of displaced liquid will be calculated. The weight of displaced liquid will be volume of liquid displaced into density of liquid into G. If depth of submergence of solid is h and its area of cross section is A, in the form of cube है, इसको ऐसे दिखा सकते हैं. The shape is not important, but if its cross section area is A and depth of submergence h, then we can say that volume of liquid displaced is AH. And if density of liquid is rho L, this is mass of liquid displaced into G कर दें, then will be weight of liquid displaced, and this will be the buoyancy force or upthrust, you can say. This value at temperature T will be written as initial area, say A naught, into this expression that we should know, area is changed by factor 1 plus twice of linear expansion coefficient into delta T. If it is A naught is the initial area, then area at higher temperature delta T will be this much. Similarly, liquid density, if initially it is rho L naught, then after temperature raised by delta T, density will be reduced, and the reduction factor will come in denominator, and this value will be 1 plus gamma L delta T, right? This is slightly unknown to lesser people. This is slightly uncommon result. This is easier to remember, but here people may commit mistake, right? So be careful. So at temperature, which is increased by value delta T, the buoyancy force expression will be this much. I have replaced area and rho L at higher temperature by this expression and rho L by this expression. I have kept H same according to the question. So thrust expression will be this much, and weight of solid is not going to change with temperature, because weight of solid will be constant for all temperature. So this equation must hold at all temperature. That means if we change the value delta T, left hand side since not changing, right hand side should not change. This is possible only if this expression is independent of delta T, and this can be made independent of delta T if this expression and this expression are equal. That means if we equate these two, we will get gamma L as twice of alpha s. This is a simple question, but It is mistake prone because these topics are a bit less popular. People are more engaged with mechanics and electrostatics. These topics are taught a bit casually, so you should be recalling these basic relations, right?